over the last month, we have been solving quadratic equations, and we've learned different methods, how to use those different methods. And this week, you're going to focus on choosing which method works best in which situation. So before we look at some problems, I do want to go through and kind of recap all the different methods. So we're going to create a chart. For the 4 methods we've learned. Okay, so go ahead and draw a chart. Doesn't have to be perfect, doesn't have to be huge, but we're going to go through each of the 4 methods. So the first method we talked about was factoring. Okay, so that was the very first method we discussed. And when we're factoring, the first thing we need to do is look to see if there is a greatest common factor. So if there's a GCF that I can pull out. And remember, this is all for different ways to solve quadratic equations. Okay, so the ultimate goal is to solve, to get the variable by itself, to know what x is or whatever your variable is. So first step is GCF. And then we went to the super x. Now, in order to use the super x, for our purposes, it'll change when you move to IM3, but for our purposes, the highest exponent is a 2. So if you don't have a 2 as your highest exponent, you cannot use the super x. So if you pull out a GCF and there's no longer an exponent of 2, you have to stop. And then in some cases, there will be special cases that you can use. So mainly we focused on difference of squares. Okay, if you notice difference of squares, you can use the special case for that. But to recap what the super x looks like, on the top of your super x, you have a times c. On the bottom is b. On the top parts here, you have your a term plus whatever your variable is. So I'm going to say x. And then these 2 parts are your factors. So what 2 numbers multiplied to the top and added to the bottom number. Okay, so these 2 numbers multiply to that top and add to the bottom. Now, one last thing that you need to remember in order to use factoring is that your equation must be in standard form. So it should be ax squared plus bx plus c. And because we're solving, it's going to be set equal to 0. So there's kind of a recap of factoring. The next thing we looked at was taking square roots. So taking square roots was the next one we looked at. There's not a whole lot with this one, but you do want to remember if you are solving, and take a square root, you need a plus minus. So anytime you are solving an equation and you take a square root, you need a plus minus. Okay, so that's going to help you, that's going to give you your 2 answers that you need. We're going to look at some examples in a second, but something that might be helpful as you are determining if taking square roots is the right option for you is there is no B term. So if there's no B term, taking square roots might be the best option for you. Or if you have quantities. So that looked something like x plus 2 squared. Now you can multiply that out to put it in standard form, but if you have a quantity or there's no B term, it might be beneficial for you to just take square roots. Let me just give you a couple examples. So maybe something like x squared equals 100 and, let's just do, 169. X squared plus 5 equals 0. 2x squared minus 7 equals 3, or x plus 1 squared equals 15. So all of those would be examples of when I would probably take square roots. So again, you'll see you'll have no B term in any of these, and then you have quantities there. The third method that we looked at was completing the square. And the first thing is we want to make sure it's in the proper form. So we have ax squared plus bx plus something equals a constant plus something. And we're going to fill in those blanks. So in order to fill in those blanks, you're going to use b divided by 2 squared. That's going to give you what you fill in. And the reason we have one on the left and the right is because when you're solving an equation, whatever you do to one side of the equation, you have to do to the other side of the equation. Some things to remember. Once you fill in the blanks, you are going to factor the left, and you're going to simplify the right. And I'll add the word side there. So factor the left side, simplify the right side. Another hint for you is that whatever you put into that blank spot, that blank will always be positive. Because even if it's a negative up here, a negative squared, a negative times a negative is going to give you a positive. So this blank will always be a positive term, which is why we do the pluses here, which is why we don't leave it open for plus or minus. It will always be positive. And then probably the one thing that most people forget is your A value has to equal 1. So if you're in this form and you notice that A is not 1, remember you need to divide through in order to get A to equal 1. Okay. And the last one we looked at over the last couple weeks was the quadratic formula. So first things first, the quadratic formula is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. You want to make sure that you are in standard form. So again, ax squared plus bx plus c equals 0. You have to be in standard form in order to use the quadratic formula. And the nice thing about the quadratic formula, even though it's a lot of work, it always works. So as you're solving equations this week, if you can't find one of the other 3 cases to use, the quadratic formula will be a good option for you because you know it will always work. It does take time. There are some points where if you're not careful, you can mess up, but it will technically always work. Okay, so let's look at a couple problems. And talk about, what the pieces of them are and see which one maybe would work best. Now, multiple methods could work, right? The quadratic formula always works, but that doesn't mean factoring or completing a square or even taking square roots won't work either. So you have some options. Okay, so not only are we going to choose our method, but we are going to solve. This week it's going to be important that you can identify why you're choosing a method and have an explanation for it. So let's look at m squared plus m equals 12. Okay, so we're going to choose our method. So I'm going to just flip back here real quick. We can maybe try to factor it. That could be an option, right? We have all the pieces for it. We have a square term, our linear term, and our constant. We would have to move things around. We're probably not going to take square roots because there is a b term, so you can't take square roots there. We can use the quadratic formula because we know that's always going to work, and we can use completing the square. So if I were you, I would pause the video and try a method and see if it works and then come back. Okay, so for those of you that tried it on your own, you may have gotten stuck, you may have gotten through it. Here's something that I think about. It's in the form for completing the square, right? All I have to do is add my blanks. But I know that my b term is a 1. Okay, so if I go to plug it into, now I'm not saying I'm using completing the square, but if I go to plug it into b divided by 2 squared, that's going to give me a 1 divided by 2 squared, which is a 1/4. So that's what I would be adding to those blanks. Now, that means you potentially are dealing with fractions. And some of you may have started completing the square and noticed that you didn't want to deal with fractions. And that's fine. Can you? Absolutely. If you know how to add and subtract fractions, you don't have a problem with that, then I would continue with completing the square because it is already in that format. I, however, am going to rewrite it in standard form and see if something else pops out at me. So I'm going to subtract 12 from both sides, giving me m squared plus m minus 12 equals 0. So now I'm in standard form. I can either factor or I can use the quadratic formula. Personally, I'm going to stay away from the quadratic formula unless nothing else looks like it's going to work out nicely. So I'm going to try to factor. Okay, so if I factor, I know a is 1, b is 1, and c is negative 12. I can look at all three of these and say there is no greatest common factor, so that tells me I'm going to go straight to the super x. So on top is 1 times negative 12, which is negative 12. On the bottom is 1, and then I have a 1m and a 1m. So I'm looking for two numbers that multiply to negative 12 and add to 1. Okay, two numbers that multiply to negative 12 and add to 1. And those numbers are 4 and 3. And in order for this to be a positive 1, it's going to be a negative 3. So 4 times negative 3 is negative 12. 4 minus 3 is 1. So I know that works out. Next step is to write it in factored form. So m plus 4 and then m minus 3 equals 0. Okay, make sure you're writing it out. Now we're going to take each of those factors and set it equal to 0 so we can actually solve. So m plus 4 equals 0. M minus 3 equals 0. If I subtract 4 from both sides, I get m equals negative 4. And I'm going to add 3, so I get m equals 3. Okay. Completing the square would have worked. Again, you would deal with fractions and you'd continue to solve, but you're going to get the exact same answers. And in this case, quadratic formula would have worked. So I'm going to write down here so I can factor this problem. I can complete the square, and I can use the quadratic formula. All three of those methods would have worked for this particular problem. Okay, some would have been a little more of a challenge, especially if you don't like fractions, but all three of those would have worked. Okay, let's look at another one. Let's look at 2x squared minus 10 equals 16. So again, if I were you, I would pause the video, take a second, and at least determine what method you're going to use and try to get through that method before you continue just watching the notes. All right, as I look at this problem, I see my ax squared term, I see constants, but I don't see a b term. So that indicates to me, based off our chart from before, that I'm going to take square roots. That will probably be the easiest method. So in order to take square roots, I want to get that x squared term by itself. So I'm going to start by adding 10 to both sides. 2x squared equals 26. We're going to divide by 2. X squared equals 13. So now that x squared is by itself, I can take the square root of both sides. And remember, when you're taking the square root and you are solving an equation, you have a plus minus. So x squared equals plus minus, and I have to look at the square root of 13 and see if it's something I can simplify. It's not a perfect square and it doesn't break down, so my answer is just going to be x equals plus minus the square root of 13. So I know for this problem, I can take square roots. Now, if you tried to factor, you probably got stuck. You will never be able to factor a problem where the solution is not a whole number or a fraction. So if you end up with a radical or an imaginary number in your answer, that's not something that would have been able to be used for factoring. We probably could complete the square, but then the b term is 0. I think that might get confusing for some people. The other easiest option would be quadratic formula, because again, that's always going to work. Okay, so those would have been the two options I would have used for this particular problem. Let's do one more. Let's look at x squared plus 2x minus 7 equals negative 4. Okay, so there are a couple options with this one as well. Again, I would pause the video and try one of those options and see if it works. If it doesn't, try something else. So your answer is never going to be no solution, I can't do it. You need to try a different method if the one method you are choosing or you chose did not work. Okay, so let's see, for this last one, because it's kind of already in the form for completing the square, and I see that b is a even number, it's probably going to work out a little bit nicer than it would have up in number 1. So I'm going to complete the square just to give you a different method. So we have x squared plus 2x plus something, and in order to get that something, I needed to add 7 to both sides. I should have done that first. Okay, so I'd add 7 to both sides, equals, so negative 4 plus 7 gives me 3 plus my something. Okay, so I have to move that constant term to the right-hand side before I can do anything else. Now I want to fill in the blank, and to do that, I'm going to use b divided by 2 squared. So b is 2 divided by 2 squared is 1 squared, or just 1. And remember, that answer is always going to be positive. Okay, that's going to always be positive. According to our chart, and if you remember all the rules, the next piece is going to be to factor the left-hand side. Now you can use the super X to factor, or you may remember that this value here, right before you square it, is actually what your factor is going to be. So x plus 1 squared. And really, again, you're looking for, if you plugged it into the super X, you're looking for a number that multiplies to 1 and adds to 2. Well, the only two numbers that multiply to 1 are 1 and 1, and 1 plus 1 is going to give you 2. This will always be a perfect square trinomial. Okay, so this term right here in the middle, right before you square it, will always be what you would get. And then I need to simplify the right-hand side. Now this looks like taking square roots, so I'm going to take the square root of both sides, giving me x plus 1 equals, plus or minus right away, the square root of 4 is 2. I'm going to subtract 1 from both sides, so x equals, now before I split this up, you're going to take your negative 1 and place it out in front of your plus minus. Okay, we're not going to add it to that 2 quite yet. So I have negative 1 plus or minus 2. At this point, you're going to split. So negative 1 plus 2, negative 1 minus 2. So you can actually simplify those answers. So you end up with x equals 1 and x equals negative 3. Okay, so we obviously, for this problem, we were able to complete the square. This particular problem, because of our solutions, would have been factorable, so you could have factored this problem and gotten the answer. And of course, you could use the quadratic formula and also get the answer. This problem you would not be able to take square roots on. Okay, so those are some questions that you want to ask yourself as you go through to solve these problems. But the big thing is, do not give up. If something doesn't work, you're going to have to erase or cross it out and start over and choose a different method.